We're go to math.com, click on the calculus. Let's go down to limits at infinity and 4-2. Well, I had it come up there. There it is. So this is what we're going to be looking at. Of course, here's the graph to this. We got the limit as x approaches negative infinity to plus 5 over x to the 7th. So we're going to want to write that down. The limit as x approaches negative infinity 2 over, or 2 plus 5 over x to the 7th power. Right? And of course we can look at the graph here, get an idea. 1, 2. Looks to me like we got a horizontal asymptote at y equals 2. So that's what we're going to kind of look at here. So the best way to look at this as though it has one horizontal asymptote coming in from the, or we're going to the left. In a previous problem we did a little trick where we threw the negative out front. We're obviously not going to do that this time. So let's see here. Let's write this out. We have the limit as x approaches negative infinity of 2 plus 5 over x to the 7th. Now if we broke this up into two separate limits, the limit of a constant is just the constant, okay? And that would be, you would just be left with 2. And this one here, no, whether we're going to the left or to the right here, to the right means we're going to the infinity, and the left means we're going negative infinity. But no matter what happens here, this number is going to converge to 0, right? Is going to converge to 0. I mean, it doesn't matter. Okay. Also, let's look at it this way. Let's say that our function f of x is equal to 2 plus 5 over x to the 7th. And I'm going to rewrite this as 2 times x to the 7th plus 5 over, we'll get one single fraction here, over that. And if you were asked to find what is the horizontal asymptote, well, the horizontal asymptote, remember you look at the two leading terms, well, the one in the top is 2x to the 7th, has a power of 7. The bottom, there's only one, has a power of 7. So remember, you just take their coefficients. So the horizontal asymptote is y is equal to 2. Y is equal to 2. Okay? That's the horizontal asymptote. Now, so it doesn't matter if we're going to the, if we're heading off in this direction here on the number line, right? Heading towards negative infinity, it's still going to be 2. It's still going to be 2. Okay, so we got to look at that. Now in a previous problem, I believe it was 4 dash something, 3 dash, 4 dash 2 or whatever it was, we had to deal with those radicals down in the denominator. It wasn't so obvious because we had basically two horizontal asymptotes, and they kind of suggest they want you to do that numerically, but a lot of textbooks suggest doing it numerically when you have two horizontal asymptotes and an irrational function. But anyway, let's just use some common sense here, okay? So as you can see, the limit of a constant is just the constant. And of course, no matter what number we plug in down here, as this number gets larger and larger and larger, the whole thing goes to 0. Right, so we're left with 2. We're left with 2. And of course, we can look at the graph here, and that's exactly what this horizontal asymptote, what this y value is converging to as x goes to positive infinity and as x goes to negative infinity. X goes to negative infinity. All right. Click that and make sure that's good, and it is. Alright, so come on back to gotomath.com, practice that, and maybe we'll chat. I don't know. Alright, bye.